guys, this is Jacob. Today I'm making a video to show you how to do F5-TTS fine tuning. So we have another video to show you how to use F5-TTS the easy way using Gradio. So today I'm making another video to show you how to do the fine tuning using Gradio, which is the easy way. So F5-TTS recently have updated the repository. There are a few things have been changed. We'll also cover that in this demo. So that being said, let's go to the Kaggle notebook. So first create a notebook called F5-TTS fine tune, or maybe any other name you want. So we first do the cloning, first do a git clone, and then clone this to the local notebook. So we have to run a pip install -e and dot. So this is actually going to install all the dependencies because they have recently updated the project to the PY project. So they use this command to actually run all the dependencies. Then next we can have to download this all the model files. So this only exists in the F5-TTS Hugging phase. So I think they don't have that in this README, but the model that exists in the Hugging Face repo. So just download that because this is going to be used in the fine tuning. And basically they have PT and also safe tensors. Just try both. I think the PT is used, but just download both. And then after that, just move this to the F5-TTS base folder. So they have a strict structure to load the model. So just go through these CKPDS checkpoints, F5-TTS base, put both models to this folder, the exact same path, and then do the we have to expose everything to the public, so just use the ungrok, and then create a function to run bash command within the Python, then grab the token from the ungrok console and paste it here. And after that, we just point the ungrok public URL to the Gradio local port, so it's localhost 7860. So that's all we need. And then after that, make sure that you run this command. The Actually, no, this is a command that is gonna just the new command that's for the Gradio. So if you want to just use that to inference the new F5-TTS, you use this command. But we're gonna do the fine tuning, so it's a different command. So before we run this fine tuning command, we have to also fix some of the issues that the original code base has. So basically, the utils file in the F5-TTS model, there are a couple of issues with the encoding. So just scroll to this line, which is the assert vocab car map. So this is gonna basically assert the first character in the vocabulary, which is the tokenizer, to be empty. But this is not exactly gonna be empty if you just use the UTF-8 encoding. So when you read the token from the vocabulary of vocab.txt, this has to be changed to UTF-8 seek. So then it will um, update, basically read everything as a this first character as empty string. If not, then we'll actually add some strange characters, which is not going to be empty, so this will fail in here. So you have to change that to the UTF-8 seek, and also the custom. If the tokenizer is custom, you have to change that as well. And then after that, you just save this file, which is just write this file, and um, you also probably have to, let's see if there's anything to update. I think that's the yeah, that's the only place. So, but you can see that they actually read from this vocab, right? So this is actually default vocab, but you have to basically use the one that you created later from the Gradio, um, which you have to use the default vocab. So you have to copy it over. So which is this section we're gonna cover. So you have first because the default name for this project is called MySpeak pinging. So you have to make a directory because that doesn't exist yet. Just make a directory, and then the default project is called Amelia ZHEN pinging. So the vocabulary doesn't exist yet. Just use the original vocabulary, which is a tokenizer. Copy that to the MySpeak pinging vocabulary. So this is needed because this is going to vocab txt. The original one is going to tie to the default model. So because the model is very like takes a lot of time to train, so it's actually fairly big. The vocabulary has to type the default model. If you have your own model, you can use your own vocabulary. But in this demo, just use the default one. We just use a different data set to fine tune it. And then finally, you can just go to the F5-TTS folder and then just do F5-TTS fine tune Gradio, so which will spin up at port 7860. So let's go to the Gradio. So this basically is the interface. So you can see that's very nice. And then the default project name, we can see that's MySpeak. So it's MySpeak pinyin as a project name. So because we speak the tokenizer type as pinyin, that's why we have to stick to the original naming convention. Once we do this vocab copy and also some of the other setup. So first, I will have to go to the transcribe data. So this is your own sort of the voice sample. So voice sample, and then you can get some of the free samples from the Kaggle dataset. So you can just use the Kaggle.com datasets, and then these are some of the samples that I found on the dataset public datasets. Um, so feel free to use any set as a sound dataset you can find. And then let's go back to the Gradio. So then use that data set. So and then transcribe that. So you can see this is actually can be transferred to some of the segments. So then so you can see this. You can actually hear that
Cross
also.
bun.
So if you look at the
A zestful food is the hot cross bun.
so this is basically the sample, right? The tags and the sample. So if you look at the folder from the data here. So you actually should see something in this folder, right? The waves. So you can see that's actually the different segments they converted to. So that's basically from the prepare data process. So once you actually get all this data transcribed, so you can click the prepare data, which is gonna um, prepare everything from those samples. So you can see the data that's gonna read from, and also the metadata, which is the speech format, the audio file, and also the text, so which you can see from the transcribe here. So you can prepare data, and then make sure that you don't click the create vocabulary from dataset, because we're gonna use the default one, which is gonna tie to the model. So don't use the one, don't check it here. So this is when you actually have your own model, you can check it from here. Then you just click prepare, so you'll have the everything be prepared. So also this is the select the sample. So you can see that's you can click.
Tastes fine with ham.
So you can see basically these are
A
the
salt
samples.
pickle tastes fine with ham.
Okay, let's go to the third tab, which is train. So after everything is prepared, go to the train data, and then you can select the model as FFTTS and click fine tune, and also the batch size is frame. And also you can tweak the params here, or just keep it as default, and then select the mix precision as FA16. Then we can start training. So I did all the training before the recording, so you can see actually the training is completed. And then you can actually just go to the model task. You can test model, and then make sure that you select the checkpoint as the model last. So this is basically the one you can run. This is basically what that you just trained. Um, Also, make sure that this ref task is you can click random sample. You just have a reference text, and here's the reference sound.
A zestful food is the hot cross bun.
Okay, here's basically the generate text. You do a voice cloning, so you want to copy the voice here, and then also the model that you trained, and apply to this text. So let's just click the inference, so you can see basically this is generated, auto generated. So you can
If
hear
this
that.
tutorial is helpful, please subscribe, like, or comment. Thanks for supporting the channel.
And this is original sound.
A zestful food is the hot cross bun.
Right, so you can see that's actually really nice. So it voice clone very nicely. So hopefully this is helpful. And if you do like this video, please subscribe and like or comment. Or if you have any questions, just leave a comment below. Thank you so much, and thank you for supporting the channel. See you in the next one.